Alright, so hope you all had a great spring break. That shot there is of Julia Pfeiffer State Park. There's a waterfall that flows into the ocean. It's pretty nice. One of my former students told me about it, so I spent the spring break in hiking mostly. A lot of hiking in Big Sur and Solvang and Morro Bay and things like that. Really beautiful countryside. Got eaten alive by mosquitoes. There's the Big Sur coastline. Very steep, very dramatic, covered in mist. It's very cool. Good times. There was a forest fire there a while back and it burned a lot of the trees. So a lot of the trails and stuff were closed, but even still, I got like a dozen hikes and it's pretty fun. So, yeah, let's talk about inheritance some more. So, you drove all the way to Pfeiffer only to find the road blocked off due to COVID. How could COVID block the road? Like, that doesn't even, I don't know, that doesn't make sense to me. Yeah, there's two Pfeiffers. There's the one in the north, which was named after the parents, and then there's Julia Pfeiffer, which is, 20 minutes to the south, something like that. And I camped in the parents' Pfeiffer Big Sur and hiked up to some waterfalls, and it was really nice. So, yeah, let's talk about inheritance a little bit more. We're almost done with inheritance. One thing that needs to be mentioned is the use of a virtual destructor. I apologize for not showing that to you before. This homework assignment is inspired by my brother-in-law. We were hanging out over break, and he told me about this big refactoring problem he came up with for people to do as practice. Basically, the notion is he gives you a working program that's horrible, absolutely horrible. Like one of his friends is like, I don't know who hurt you, but and you have to refactor it. We're going to do something a little different. You're going to write it from scratch. You're going to do a greenfield assignment, blank file, solve the problem. You're going to have to use inheritance because, again, I'm trying to emphasize inheritance a little bit heavier this semester than I do in most semesters, simply because even though I'm not a huge fan of inheritance, a lot of people are. And my brother-in-law's solution uses inheritance. And so, get used to it. The one thing I forgot to mention before is the use of a virtual destructor. So destructors need to be virtual. If you don't make it virtual, I believe the compiler will yell at you. So if we ++ main.cc, we should get a warning. No, maybe not. And playing ++ -warn on everything. Yeah, man, a lot of things it's mad about. I've seen it warned before if you do not have a virtual destructor. And so the reason for that is because if you have a shared pointer to a shape or something like that, it'll just call the base class destructor by default. You need to make it virtual so that it figures out what type it is and calls the right destructor. So for this assignment, maybe it's not that big a deal because we're not like newing or deleting anything. We should be using basically almost no destructor, but good habit to get into. And you do actually just kind of need it. If you're going to be doing inheritance, you need a virtual destructor. And it's very common to just set the virtual destructor equal to default. And that means use the compiler generated destructor for me and just leave it at that. Rule of 0, very nice stuff, right? No news, no deletes means no copy constructor, no assignment operator, no destructor, no move assignment. Just let the compiler do it for you, and it's nice. Okay. So that's the last little bit on inheritance we need to do. So let's talk about the assignment. So the assignment is going to be in two parts. The first part you guys are going to write, and basically the assignment is you're given a bunch of points. You have to categorize the points. Is it a triangle? Is it a rectangle? Parallelogram? I don't think that's in there. He was talking about it though. Is it a line segment? What is it? And inline, good question. Let me talk about that in a second. Is there an input tester? Not yet. There will be. So basically, given a set of points, recognize it as a triangle or a rectangle or whatever. And for triangles and rectangles and things like that, they have to be a closed loop. So a triangle is actually 4 points. 1, 2, 3, and then the fourth point is the starting point. Okay? If the starting point and the ending point don't line up, then it's an open shape, right? And it's an other. Okay? And so a rectangle is actually 5 points. The starting point and the ending point are the same point. Okay? And a rectangle has to be 90 degrees and that kind of stuff. All right. So what you're going to do is you're going to start with a blank file, and you are going to read from standard input until the user hits Control D. And this is a very common construction that I don't know if you've done before. I know some of my assignments might have done it this way, but basically enter point 1010, 2010, 2020, 1020, 1010, Control D. So Control D sends the end of file character to a stream, and it closes the stream essentially. And so you can check for it by just saying if not cn, right? So every time you do a read, check if not cn. Afterwards, did an error occur? If an error occurred, then we're done inputting points. And so all of these points are not actually integers, they're actually doubles. I type them in as integers, oh well. And basically you're gonna just enter a bunch of points, and then I am outputting the points and saying that is a rectangle. Okay. You can check it with EOF as well, yeah. It's a .EOF, yeah. If you want to be more precise, yeah, use .EOF, because an error can occur if you try reading like squirrel or something into a string, like a squirrel into a double, then an error will occur. In this case, yeah, probably checking for .EOF is better. Yeah. Okay, so that's the assignment. Basically, my brother-in-law presented this to me, and then we were sitting there waiting for my parents to get home. So I'm like, I'll just cut it up. So I pull out my laptop, and it took about an hour or so to do. His GitHub page has like the full README file on it. I've posted it on the chat. Maybe I'll pin it. And I'll open a copy up here. So these are the 6 different things you have to recognize, and then he kind of explains what makes up each one of the things, like what's a line segment, what's a point, that kind of stuff, what's empty. Okay. And let me pin this on chat. There you go, so you can find it whenever you want. It'll be due on Friday. And it took me about an hour to do it. And the reason why I'm making it due on Friday is because I'm actually not having you do the whole thing. All you have to do is recognize which of the 6 shapes. His code actually has a lot more than that. Like what is the perimeter of the rectangle, and what is the angles of the triangles, things like that actually require trig and stuff like that to figure out. Nope, we're not doing any of that. All you have to do is just categorize the points that are given to you, and that's pretty easy. Okay. Mainly, this is an exercise in you making a class hierarchy again, and doing a little bit of input, output, data processing, kind of teaching about end of file a little bit. And then on Friday, what we're going to do is I'm going to take everybody who did the assignment, and I'm going to give you somebody else's assignment for part 2. And so you have to refactor other people's code, okay? And that is kind of getting at what my brother-in-law is doing with that. He started with he gives the people who do the exercise a working implementation. It passes all the test cases. He gives them tons and tons of test cases, and he gives them code that passes 100% of the test cases, but the code is obnoxiously evil and horribly written and inefficient, and just has like one function that does the entire code base, and it's called like something from Harry Potter or something like that. And so it's a task that he made, and my brother-in-law presents at conferences and things like that. It's a task that he made so that people can kind of work on it for an hour at a time over a month, and kind of clean it up and get it faster and less terrible, you know, as my viola instructor used to say to me. Play that again, just less bad. best criticism ever. Yeah, just less bad. Play it less bad. Thank you. I appreciate it. He was my substitute viola instructor. Devinda, who's I think teaching at Fresno, high school, Fresno State High School or whatever it's called, University High School. He gave good feedback, but my substitute Veal instructor was just very kind of sarcastic. Okay, so all you have to do is make a class hierarchy. Basically, you're going to make a function that will take a vector of points and then return a shared pointer to a shape. Shape would be the parent class, and it's going to have 6 subclasses, child classes, 1 for empty, 1 for point, 1 for line segment, and you're going to return a pointer to one of those things. Each one of those things is going to overload the get type method here. And so if you return an empty, well, there's not a whole lot on an empty, right? So you just override get type and return in. So when you ask it, hey, who are you? I'm an empty. Okay, cool. That's it. So you're going to make a class hierarchy. 5 of your points. Half the points on this assignment are from doing the class hierarchy. And you have to build the data, the member variables and things like that will be used by the other person. Okay. So for example, the point class must have an X and a Y value. The other has to have a perimeter length. Basically, if you have a bunch of lines, you return the total line segment distance, things like that. A line is 2 points, that kind of stuff. You have to have all the member variables there, but you don't actually have to do anything with it. Okay? So in the part 2, they're going to take your code and add things like return the length of the line, return the area of the triangle, that kind of stuff. You just need to kind of set it up for them, like put the ball on the t-ball, and then they can tee off on it. A triangle is 3 points, or you could use an array. I think I originally did this with an array, but I messed around with it a little bit for some reason. So that's all. It's 5 points, 5 easy points. It's literally like, I don't know. I always hate giving time estimates, but it's not very much time to just set up the classes. Okay. What is Constexpr? Great question. So one of the fun things about working with my brother-in-law is that he's not a C++ guy. He's a C# guy, and mostly he's done other languages too, but his primary language is C#. And so C# does things differently from C++. C# is like Microsoft Java, right? And so I was kind of putting some things in there like Constexpr, just so that I could like tell him like about the kinds of things that if I can type it right, Constexpr. So I could tell him about kind of some of the stuff that's in C++, and I also kind of wanted to show it to you guys so that you can ask me, hey, what's inline mean? What does Constexpr mean? Okay. Before we do that, one thing we need to talk about is comparison. Floating point comparison sucks because if you add 5 to a number and subtract 5 from a number, in ints you get the original number, right? X plus 5 minus 5 equals X. Not true necessarily with doubles. Okay. Whenever you do plus or minus and comparisons with doubles, you sometimes get numbers that are very close, but not exactly the same as the other one. And so it's very common to have a function like this that will see if 2 numbers are the same by putting them within a error of each other. And so I was like, hey, how about I use like an epsilon of like 0.01? He's like, that's the number I used. I'm like, cool. And so this code here is literally exactly the same as this code here. So it's a constant, and it's a constant expression. So can you rewrite the code for part 2? You have to start with their code. Okay, you will be rewriting it, right? But you can't just like throw theirs away and like use yours. Like I want to see. That's why I'm getting screenshots from everybody. I want to see you using their code and not just like down the trash, and then starting over. Okay. There is a note on the README file. You cannot have comments in your code. Every comment that I see in your code is -1 points. You can use comments in your code while you're writing it for your own development. I know. That's why there's like a little devil emoji on that. I am teaching you guys bad habits because the whole point of this is to be a refactoring exercise for the other person who gets your code in part 2. And if you make it too nice and explainable, then it'll be too easy for them. So sounds like we need a Git workshop. Yeah, that's probably a good idea. Probably a good idea. So, yeah, no comments in your code. Every comment is -1 points. So, you can put comments in, but when you turn it in, remove them. And you can save a copy yourself with comments, and then if it makes you feel better that way. So what is Constexpr? What is the difference between constant and constant expression? So my brother-in-law told me in C#, and I'm not a C# person, so if I get this wrong, blame me, it's not his fault. C# has a read-only keyword and a const keyword. So read-only means it is set at runtime but can't be changed. Or it's set at runtime or compile time. You guys understand the difference between runtime and compile time? Compile time means the compiler can figure out what value it is. Like here, this value is always going to be 0.01. Always, forever, can't ever be not 0.01. So this is something the compiler can determine, and then it can remove the variable entirely from the assembly code generated because it's always going to be 0.01. There's no reason putting it into a variable, right? No, it won't take up any stack space, that kind of stuff. Now, in C++, you might think, okay, that's what const means, right? Like it's compile time determinable. Wrong. So in const in C# means compile time determinable. In C++, const means read-only, and Constexpr means const. So Constexpr means the compiler must be able to figure out what it is at compile time. Const means it can only have its value set once, and once it's set, it can't be changed. So if we look at down here, you can see that this value here is not compile time determinable. It's actually reading from the keyboard, and whatever value is typed in, 10 or whatever, gets set into the point here, and it can't change after that point. That point can't change after that point. Yeah. Right? It's can be set once, right? But it's not. If I tried making this Constexpr, watch. If I tried making a Constexpr, the compiler yells at me. It's like I can't figure out what this is at compile time. And so that's the point of Constexpr, right? And it is const, it's not Constexpr. So it doesn't change after it's made, but it can't be determined at compile time. Those are two very similar but different concepts, right? And Constexprs are const. Red is foaming at the mouth right now since you mentioned his favorite language. Yeah, comment out the comments. That's perfect. Yeah, and so I actually think C#'s vocabulary makes more sense to me because because it's not a constant if you can change the value, right? You know what I mean? Like it's not actually constant. Read only is probably a better keyword, right? You can set it, but you can't change it. Will you know which classmates' code you'll be receiving? No, it will be random. You can't pick either. So, yeah. And so why Constexpr? So this is a direction the C++ language has been moving in over the past 10, 12 years, something like that, which is to push more and more work out of runtime into the compiler. So if you have some work that you can figure out what the answer is, like let's say there's a for loop that always does the same work every time you get to that piece of code, what you can do is actually have the compiler run that code, figure out the result, and then put the result in, right? And then you don't need to do all that work at runtime. It has the right result already there. And so that's the point of Constexpr. Constexpr, and there's if Constexpr, which allows you to have if statements that run at compile time, not at runtime and things like that. So if the compiler can figure out which branch is correct, it'll do it. And it'll cut out all the other code and stuff like that. So that's just a brief introduction to a big push the C++ language has been moving in, which is to try to not waste effort at runtime. Like if you can pre-calculate the results and then just use them. It's much faster. So what if you get code that doesn't work? You will only be given code that is passing 10 out of 10. Okay? So you are going to be given working code, and I'm going to personally go through the code and pick the ugliest code So if you are worried about code beauty and things like that, don't. Take the opposite approach. Make it ugly. And I will be passing out comment-free, ugly code. You make it inefficient if you want. Loops inside of loops inside of loops. And I will go through and flag the ones that are the absolute most appalling and give those out to people for part 2. So, Bywater is, yeah, we were talking a little. Hey, is Bywater here? Oh, he changed his name. I see. Is that how you spell the read-only keyword in C#? Because I'm not a C# person. Can you verify that that I'm not lying to the good people of the class? It's called read-only, and so is this right? Read-only means it's set at runtime, and const means it could be determined at compile time. Is that correct? Excellent. Cool. Thank you. So, yes, that's Constexpr. And like I said, if you change that Constexpr to const, it actually doesn't affect anything, because it's actually a constant expression. Because an expression, right, is anything you can put in parentheses, and it actually will generate exactly the same code. But if you put in Constexpr, it will detect if the thing that you think is compile time determinable is not, and it'll warn you, or not warn, it'll not compile. So use Constexpr anytime that you think that something should be determinable at compile time. Save you some headache. And so here we have a double comparison. Like if you're going to compare two doubles, we want to see if they're near each other, and if they're within 0.01, they are considered equal in this code at least. Okay, you'll see something similar to that in most code bases. Probably epsilon should be a parameter. In fact, I'm just refactor this, I guess. See, there's a refactor right there. Okay, so the code will still compile and it'll be treated just the same. But now, if I ever want to change the error that it compares within, I can do so. Actually, let me put it back. Oh, simply because I want to leave that keyword in there for future generations to come. Okay, so what does inline mean? So a lot of people will give you a wrong answer on this, including a lot of references will give you a wrong answer. So the kind of right, but actually wrong definition is inline means the compiler will optimize away the function. So what does that mean? So let's say I have a function called foo, and foo returns 42. Okay. So there's actually overhead to calling a function. Let's see if there's anyone in here. Bell knows. Probably Bywater. Walker is here. Good to see Walker. And Curly knows. Yeah, there's a fair number of people that know what I'm talking about here, but most of you don't. And if you actually look at the assembly code for this, when you do a function call, you push things onto the stack, and you do things, you return, and there's actually a lot of lines of code that take place in order to just return 42. And so, like if we were to, for example, say int x equals foo, like that, if you actually do that whole function call, it can actually be fairly expensive. It might be like, I don't know, 10, 20 cycles. I don't know. Depends how it's done. Whereas it should just set x equal to 42, right? Like this should just put the value 42 into x. But every time you have a function call, there's a lot of overhead. Not a lot of overhead, but a fair bit of overhead. And so what inline used to mean, or what people still think it means, but they're wrong, is that if you do this, if you say inline foo, int foo, like that, then what the compiler will do is this. So this is what people think inline means. In other words, if you use the inline keyword, it will remove the function call entirely and just put the code for the function into the place where it's called. This is actually wrong. It used to mean that, but it's actually wrong. And the reason why it's wrong is because the compilers can actually ignore that. So compilers are generally speaking smarter than programmers. And so if you put inline on that function, it will probably be like, yeah, that should be inlined, and it will inline it like this. Do you guys understand what I mean by inlining? Like, so rather than actually doing a function call and jumping over there and doing some stuff and returning, it just will set x to 42. Do you guys understand what that means? That's kind of a CSI 45 topic, but does that kind of make sense to you? So it's like one operation instead of like 10 or something. Yeah. Okay. So here's why it's a lie. If you don't have the inline keyword, the optimizer will still do this. Right? It actually doesn't make the slightest difference, as far as I know, if you have the inline keyword or not, because the optimizer is free to do that anyway. And so the inline keyword used to mean, hey, inline this function. Nowadays, optimizers are smarter than people, and so it generally ignores it. I think there might be some edge cases, and we can go into a compiler explorer and look at those cases. Also known as Godbolt. We can look at them and see if they matter. So let's write some code here. Int foo, return 42, and then down here int main. Cout, cout x is 42, return x, should be function. Return, did I misspell something? Ah, yeah, thank you. Too much Python. Okay. All right, so here we got ARM GCC trunk. Let's turn off the optimizer and see what we end up with. That's a lot of garbage stuff called weak function. Here's foo. Okay, so foo. So you can see this is what happens if you don't have the optimizer on. So it saves a register onto the stack. It adds 0 to the stack pointer, puts that into R7, moves a short into register 3, putting the value of 42 into register 3. It then moves register 3 into register 0. And you might be like, well, why didn't it just move it into register 0? And you would be right. It absolutely should put it into register 0. There's absolutely no reason why it does that. It then moves, so it moved the stack pointer to register 7. It then moves register 7 back into the stack, accomplishing absolutely nothing. And then it loads from the stack pointer plus 4 into register 7, and that is going to be, and then it's going to return. And so that does absolutely nothing as well because we're returning from the function. Say it's register 7, and then it doesn't pop it. Interesting. So I wonder what it's doing with that. Okay, anyway. It's got an abort in case we throw an exception or something. Let's see. Try this. No, doesn't seem to make a difference. All right. Here's main. So main calls BL is the call to foo, and then it stores the result from foo. That's going to be the number 42. Stores it into RAM at memory address R7 plus 4. R7 is the stack pointer. So you remember how we talked about there's a stack pointer that goes down every time you do a function call. Stack pointer plus 4 is our x variable. And so we are storing the return value from the function. The return value always comes in R0. We store that into variable x in RAM. We then turn right around and read from that spot in RAM and put it into register 3. You might ask yourself, why didn't we just move from register 0 into register 3? And that's a great question. We probably should. But this is the optimizer turned off. It writes bad code, right? So, and it's technically writing to X, right? X is some address in RAM, and it's that spot. It's writing to it. It then moves R3 into R0, which is absolutely pointless because it's the same value already, because it's stored from R0 into RAM. It loaded from RAM into R3, and then it moved R3 into R0. So that line does absolutely nothing. It's already the same value. It then adds 8 to R7, moves this into the stack pointer, and then returns. So that's the return X right there. So the return value from a function goes into register 0. Okay, so that is that. Let's turn on inline. Let's see if this makes a difference. Nope. Actually, that's different, huh? Oh no, call weak function. Okay. Yeah, foo doesn't exist anymore. Let's see, where's foo at? Main. Oh, there's foo. They moved it down. Yeah, it's the same function. So putting an inline there did absolutely nothing. Okay. The compiler is free to ignore it. It's free to use it. If we put in 03, then you will see substantially different code. Here's main. Here's all of main. Put 42 into register 0 and quit. Right? You guys see that? That's the whole program now. So it inlined that function and got rid of the variable. This whole code now is just main just returns 42. There's no function call. It got completely inlined away. Okay? You guys see that? And I don't know if foo is even still in here. I'm not even seeing foo. I think foo vanished into the ether. Yeah. Okay. Any questions about that? Now if I delete the inline, foo exists again, right? Because inline actually changes linkage, and that's actually what we're going to talk about next. But you can see that with the optimizer on, the foo function just puts 42 into register 0 and returns. But it's not even called from main. You see that? So whether or not we had foo inlined or not made no difference to main. Because the optimizer is free to use it or not use it. It's kind of what it used to mean. Nowadays, the optimizers are generally speaking smarter than people, and it just kind of ignores it. So what is the point of inline? The point of inline is actually to control linkage, which is unfortunate because the name is inline, right? And so we think it has something to do with inline functions, and it used to, but it doesn't really anymore, but that's still the keyword. And so we use it to control linkage. And so basically the upshot is this. Do you guys remember the ODR, the one definition rule, that a function has to be defined in one place and one place only? You guys remember that? Like you can't have two competing definitions of the same function. Well, public. Well, here's the good news. If you make your thing inline, then you can have multiple definitions, multiple redefinitions of the same function. So that's why anything that goes into a header file that's going to be included into multiple files is marked as inline. Why? Because it allows you to have two copies of read. So if one person has a copy of it, they have a copy of the function, another guy includes it, they have a copy of the function, you link them together. Without inline, it would cause a violation of the ODR. With inline there, then it allows them to violate the ODR, essentially. You can have two copies of it, and it just picks one at random to use. So hopefully they're the same. Do you guys want to see like a simple example of that? All right, so vim a.cc. That was kind of a waste of typing, huh? Okay, include a.h. Okay, so a.h has a function called foo in it. Foo returns 42, and our function's going to call foo and return 42. Okay, easy peasy, right? Well, so far so good. Now, what if we have a second file, b.cc. b.cc includes a.h, int bar returns foo. Okay, so do you guys all understand that bar is going to return 42 also? It's including the thing. It's in a header file. It's return 42. You guys all with me? So then if we go into main.cc and have it, no, go into a.cc, let's say. So what value is this going to return? We have a vote for 42 from Holman. Anyone else? 42 from Otal. Concur from Romero. It won't return anything because this code won't compile. And the reason why it won't compile is because remember what happens when you have an include statement. It's essentially doing this. This code and the previous code are exactly the same. Like when you include something, it copies and pastes the entire file into your file. It's stupid. It's stupid. Modules are much better, and modules are almost ready yet. They're not quite there, but they're pretty close to being, something I can actually lecture on and stuff. But include files, when you include something, it just copies and pastes it in there. Okay, so a.cc has a definition of foo. And then remember what's in b.cc? Well, when you include that file, that's exactly the same as if I had said int foo return 42 here. Right? So there's two different files that both are defining foo. Do you guys see how this violates the ODR? That's the problem. Okay? And that's the problem with putting definitions into header files. Because everybody that copies it gets a full copy and pasted, version of it, and then it's like, I'm defining it. No, I'm defining it. No, I'm defining it. Who has the right version? Who knows? Look at this. Which one's right? I don't know. Is the one in main that's right? Is it this one that's right? I don't know. Can't handle it, right? So if we g++ a.cc, okay, bar. So this is a declaration. That's fine. Oh, actually, I'm in the wrong file, aren't I? Okay, sorry. Then a.cc bar. Let's say declaration. This is a definition. Right? So a lot of people only put declarations into header files, and they put all their definitions in .cc files. However, if you use templates, they all have to be in the header file. So modules are in C++ 20, and they're almost good. So would it work if you added pragma once? It would not. Pragma once stops you from including a file multiple times, right? So if you say include a.h, and you did it again, then you're going to violate the ODR, right? Because you've redefined foo right here, right? And so putting in pragma once, pragma once stops you from including it multiple times, but it doesn't stop this problem where two different people are including it. And so what you end up with is a linker error, and the linker error says you've got two copies of bar. One's in main, one's in a.cc, one's in b.cc. I don't know which one's right. Okay, and so basically, solution is to make it inline. Inline means that's basically what it means. It's something called weak linkage. opposed to Peter Dinklage, this is weak linkage. Okay, and so if you do that, then everything works fine. Voila. Okay, so that is my 10-minute talk on inline. So why is inline there? No reason whatsoever. Just to provoke a question from students and be able to talk about this, because it's pretty important. If you're going to have header files, all of them should be marked as inline. If you're going to have definitions in header files, they all need to be marked inline, or you're going to have a bad time the second you have 2.cc files. It'll work fine when you have 1.cc file. Once you have 2, you'll get these redefinition errors, and you're going to be like, what the hell is going on? You know? What's wrong with modules? Nothing. They're great. They're just still rolling out in terms of implementation. The last time I tried using them, they didn't work. I haven't also checked in the last couple months, so maybe they're ready. I don't know. I'll look into it and maybe do a lecture on it. They're a massive advance forward. It's going to take a long time for like the standard libraries and things like that to get modularized. But basically, the goal, and this is another thing that C++ has been moving towards for the last 20 years, is to get rid of the preprocessor. Like all that preprocessor stuff, Bjarne does not like the preprocessor, and for good reason. It's like what you're trying to do is just say I want to use vectors, right? But what it actually does is it copies and pastes, I don't remember, it's like tens of thousands of lines of code into your code. And all of your .cc files that do this, they get all the same damn things copied and pasted in over and over again. It's ridiculous. And if you reorder, your header files, like it changes your code, which doesn't make any sense if you think about it, right? Like if I say -e main.cc, yeah. So this is my program after you've counted all the header files, 90,000 lines of code. 180 lines I wrote. The other 90,000 are just headers, right? And then if I do things like, I don't know, move these things, let me just change them around randomly like this, and do it again, you can see the number of lines of code changed. I just changed the order of the header files, and the lines of code that I have changed by 7. That's probably bad. Like, what are those 7 lines of code? I don't know. I don't know what those 7 lines of code are. But my code's different now because I alphabetized my header files. Now my code's different. What? Modules will fix that. So with modules, you just say import. Let's see if it works. No. So I should try with G++. Okay. Yeah. Maybe I'll do a talk on it at some point. They're pretty cool. Hashtag import. No. It's not a preprocessor directive. The whole point is, oh yeah, maybe I need the angle brackets on it. No. Expect a semicolon after module name. Let's see. Shut off, I guess. Yeah. Okay. Yeah, we'll talk about it later. So, yeah, modulars are cool. They're well worth a talk. What was the other thing I was going to talk about today? Yeah, the importance of learning how to refactor code is really important. Most commercial code, like if you work as a developer, most of the time you're not going to be starting from a blank file like we do here. Most of the time you're working on some legacy system. It's been around since the 70s. Nobody understands how it works, but they know the quirks, and they know if it breaks this way, you poke it with a stick and unclogs, and and so learning how to work with other people's code is really important. That's why we're doing this exercise. You're going to write half of it now. I'm going to shuffle all of your work, and you're going to work on it the second half on their code. Okay, starting on Friday. All right. Get rid of that. Okay. So yeah, the main thing is you're going to make a class hierarchy, 6-7 classes I think total, and you're going to screenshot your class hierarchy or just copy and paste the text either way. Put it up on Canvas. That's 5 points. 5 points for correctness, and that's funny. Yeah, working effectively with legacy code. Yeah. It's funny. We're going to be shuffling the assignments on Friday, yeah, so make sure you get it done. All right. Yeah, I don't remember much from the 70s. Sorry. Vietnam. Okay. So that's it. Yeah. So it was about an hour's worth of work for me to do, and I was kind of coding with my brother watching me, brother-in-law watching me. You're going to want to write a function called classify. Classify is going to return a shared pointer to a shape. And then your code should just print the type out. Okay? And yeah. So that's it. The possible options are Control D, empty, a point, line segment, other, triangle, rectangle. So that's what your code needs to do. Okay. So you have the rest of class to work on lab time. I will be here to help you out with any questions you have. So hope you guys all learned some C++ stuff today. Constexpr, inline, virtual destructors are kind of important. I kind of forgot to talk about those earlier. Yep. The why include sucks. But maybe you knew that already. All right. So I'll let you guys get at it. All right. See you.